Welcome to another Intermediate Algebra video. In this video, we're going to look at problems that have a fraction exponent. So our objectives for this video, to understand the meaning of a to the 1 over n, so a base of a, I'm going to write these a little bit bigger for you, a base of a with the exponent 1 over n. The second objective being a base of a with an exponent of m over n, and m and n just represent, they could be numbers, they could be, well, they're going to be numbers here. A, the base, can be anything. And then finally looking at a base of a and an exponent of negative m over n. So what's new in this video are the fraction exponents. And then our other objective is to use the rules for exponents to simplify expressions that contain rational exponents, meaning fractions. So, the notes page. We have quite a few notes for this section, but the notes only look long because I've rewritten all of these exponent rules. This is a reminder. The intention is that you've seen these before. So let's run through them quickly. The first rule is if you have the same base with an exponent being multiplied by that same base with a different exponent, the two exponents add together. Just like if you were multiplying x to the second times x to the third, this would mean 2 x's multiplying by 3 x's. So you have 5 x's multiplied together. This would give you x to the fifth. The second rule being a to the m over a to the n, you subtract the exponents. If you had x to the fifth over x squared, this is the same as having 5 x's on top, 2 on the bottom, 2 cancel, and you have 3 left, leaving you x to the third, so subtraction. If you have a base raised to an exponent raised to another exponent, let's take those off. If you have x to the third quantity squared, that would mean x to the third times x to the third, which would give you x to the sixth. So ultimately, those two were multiplied. The next rule, if you have two separate bases being raised to an exponent, that exponent gets applied to each individual base. This is only when everything's being multiplied. So an example of this would be 3x to the third power. So this is the same as 3 to the third, x to the third, which is 27x to the third. And the last two, the one with the negative is pretty important here. This is something that we're going to focus on. If you have a base with a negative exponent, you can fix that negative exponent by flipping its position in the fraction. So if it's currently in the numerator, you put it in the denominator and then it has a positive exponent, and vice versa. And the last one we won't use too often, I just want you to have it in the notes. Anything raised to the 0 power is 1. So the new rules. The new rules are a base raised to a fraction exponent. So if we have a single base, or there could be more than one piece there, to a fraction exponent, the denominator of the fraction becomes your index, and then the numerator on that exponent gets applied as just a standard exponent on that base. So this change becomes the nth root of a to the first, which ultimately is just the nth root of a. If it's to the first power, you don't need to write it there. But the change happens the exact same way for the second rule. A to the m over n, again the n, the denominator becomes the index, and the numerator is the exponent applied to that base underneath the radical. The last new rule first uses this negative exponent rule. So we have a to the negative m over n. First, flip its position in the fraction. So we have 1 over a to the positive m over n. And then the second rule helps us get to this final line. The second rule ultimately is the change here. It's just all happening in the denominator. oops, we have 1 over the nth root of a to the m power. So the first thing that we'll do is actually make the change when necessary, and then we'll simplify like we've normally been simplifying throughout this unit. All right, let's start to look at some examples. So the first set of examples, and I'll be more helpful here. These are the problems that are using the rule a to the 1 over n is the nth root of a to the first. That first power doesn't need to be there though. All right, so we have 4 to the 1/2. The first thing we'll do is make the change. So the denominator becomes the index. Oops. And then underneath that radical is 4 to the first power. So the numerator here, denominator is the index. So really we have the square root of 4. And then you simplify as usual. Square root of 4, 2. So 4 to the 1/2 is 2. Okay, the next one, 64 to the 1/3. So first let's make the change. The change says that denominator is the index, so it's a cube root of 64 to the first. Seems silly to write the first, but it'll help as we keep going. So it doesn't need to be there. Then we're evaluating the cube root of 64. So you might remember it by this point, but you can break it down. 16 times 4. I'm going to cheat a little and look for these 4s because I know that's where we're going. If you went all the way down to 2s, that's fine. You'd have 6 of them. So you'd bring out 2 and 2, which is 4. Group of them, so we get 4. Okay, and one more. This one, our index is a 4, and underneath this radical is the quantity 81x to the 8th, all raised to the first power. If this entire quantity is raised to the first power, that means each piece inside is raised to the first. And if it's raised to the first, well, nothing changes. So we get 81x to the 8th. Then this is what we're simplifying. So we can take 81, break it down to 9 and 9, each of those 9s, to 3 and 3. We need a group of 4, so we have 1. So a 3 comes out. Then we have 8 x's. We want groups of 4. There are 2 of them. 2 x's come out. And there's our simplified problem. So what's new is not the simplifying. What's new is making this change. The denominator becomes the index. The numerator is the exponent in all problems. Exponent, index, exponent. So there's the first rule. Let's take a look at the second rule. The second rule is a to the m over n, index of n, a to the m. Exact same thing, but now instead of a 1 in the numerator, we have an m. So something other than 1. Okay, so let's make the change on this one to start out with. We have the square root of, what goes underneath is 4 to the 3rd. Now, before we evaluate the square root, we need to figure out what 4 to the 3rd is. By hand in your calculator, 4 times 4, 16, times another 4, 64. And this is a square root, so whether you write that index of 2 or not, doesn't matter. But now we're evaluating the square root of 64, and we get 8. So again, what's new is this change. Denominator is the index, numerator is the exponent underneath the radical. Okay, the next one, negative 16 to the 3/4. What's being raised to the 3/4 here? Is it 16 or is it negative 16? Let's compare. What if it said this? Now comparing these two, what do you think the answer is? The second one, the written one, is very clearly negative 16 to the 3/4. But if there's no parentheses around it, then it's just the 16. So the negative carries down and is just part of the answer. Let's do it in a different color. This 16 to the 3/4 will make the change. So it's an index of 4 as a denominator with a 16 to the 3rd power underneath. Okay, now we want to evaluate. You can do this a few different ways. 16 to the 3rd is quite a large number, and you can absolutely get that number and then break it down and look for groups of 4. Or we know that it's just 16 times 16 times 16. That's what 16 to the 3rd is. And then instead, we can just break down each of those 16s. They're each going to be 2 times 2 times 2 times 2. So we'll have negative 4th root of, that's for the first 16. It's for the second 16. And that's for the third 16. We want groups of 4, so it looks like we have 3 of them. So a 2 comes out, a 2 comes out, and a 2 comes out. Nothing's left inside. We still bring down this negative all along. So negative 2 times 2 times 2, negative 8. Good. Again, the new thing is the change. Denominator, index, numerator, exponent underneath. Okay, so let's go to the third one where we add in that final step. 9 to the negative 3/2. So this uses the rule a to the negative m over n. And I'm going to show you the entire sequence is 1 over a to the m over n, which is 1 over, make the change here, index of n, a to the m, all in the denominator. And we're going to follow the sequence on every problem. So our first problem, let's first fix that negative exponent by flipping it to the denominator. This becomes 1 over 9 to the positive 3/2. Then we make the change. 1 over index of 2 under the radical is 9 to the 3rd power. And then it's your call. Simplify whichever way you want to. Let's go under. It's a square root. This means 9 times 9 times 9. Each of those 9s breaks down to 3 times 3. We want pairs. So a 3, and a 3 come out. We get 1 over 27. So to review, we fix the negative in the exponent by flipping it, its position in the fraction, to make it a positive exponent. Then change. Denominator is the index, numerator is the exponent underneath, and then simplify. Okay, this next problem, we have 4x to the 3rd, all raised to the negative 2/3. So first, let's fix that negative exponent by turning this into a fraction. The entire quantity comes to the denominator, and then instead has a positive exponent. Okay, then we'll make the change. They have an index of 3, and underneath is 4x to the 3rd, and all of that is raised to the 2nd power. Before we can start taking things out, we need to clean up what's inside. So underneath, it's still a cubed root. We have 4 squared and x cubed squared. So we get 16x to the 6th. 16 breaks down 4 and 4, 2 and 2, 2 and 2. We want groups of 3. So a single 2 comes out. And a 2 is left inside. And then we have 6 x's. Groups of 3 gives us 2. So 2 x's come out. And this is as simplified as it gets. Good. All right, so this is the third of the new rules where a negative exponent exists with a fraction. All right, let's take a look at some just standard simplifying, but now they'll involve fractions. So all of those standard rules from the beginning, the rules that we discussed, the intention is you've seen them before. You can still use them when those exponents are fractions. So the first one is b to the 1/3 times b to the 5/3. And remember, if they're the same base multiplying with different exponents, you can add the two exponents together. So this becomes 5 to the 1/3 plus b to the 1/3 plus 5/3. You can add those together because they have a common denominator. That gives us 6/3. And 6/3 simplifies to 2. Now you might be wondering if you can do it the other way, which would be making the change. And the answer is yes. You could change that first one to be a cubed root of b, and the second one to be a cubed root of b to the 5th. Pull those together. Since they're like radicals, you can multiply them. It's a cube root of b to the 6th, b times b to the 5th. And then there's 6 b's. You want groups of 3. There are 2 of them, so you get b squared. Same thing either way, but you can use those rules without having to go through the change. Now, if there's only one piece, if it's only b to the 1/3, your only option is to make the change. All right, the second one has the same base on top and bottom, and remember that is a subtraction one, the rule with subtraction. So it'll be 7 to the 1/3 minus 4/3. So we subtract, we get negative 3/3, which simplifies to negative 1. And I didn't really discuss this, but it was a note on that notes page. Your final answer should always be presented with all positive exponents. So while this is a perfectly great method to get to this answer, we just need to go one step further and use the rule that fixes a negative exponent, which flips this upside down and makes it 1 over 7 to the 1st, which is just 1 over 7. Okay, and then the last one. The last one uses the rule of an exponent being applied to every base in the parentheses. So you could either write this out 5 times, times 2x 2/5 y negative 1/3. Or you can use the rule and apply that as an exponent to each. So we have 2 to the 5th, because we'd have 2 times 2 times 2 times the ones we can't see. And x to the 2/5 to the 5th power, y to the negative 1/3 to the 5th. And then apply each one independently. 2 to the 5th means 2 times 2 times 2 times 2 times 2. 4, 8, 16, 32. X to the 2/5 to the 5th power, remember power to a power, that was one of the rules, says you multiply those exponents. So it's 2/5 times 5, which is x to the 10/5, which is x squared. And then the last one, negative 1/3 to the 5th, means multiply those. We get negative 5 over 3. So sure, it comes back here. But then we can't present our answer with a negative exponent, so we flip its position. The 32 and the x squared can stay on top. The y comes to the bottom with 5/3. And there'd be a couple ways you could present this. You could present it this way. Since this objective is really just about using those rules you've previously seen, or You could fix that denominator. You could change it to be a cube root of y to the 5th. If you have 5 y's, there's definitely a group of 3 that can come out. So you could also write this as 32x squared over a y that came out, cube root of y squared. If you're not sure which route to go, check in the directions. There should be some sort of specification, and if there's not, then either presentation of answer would be just fine. All right. Let's do some practice. So this uses all the rules in a few different ways. Go ahead and pause the video, and then we'll go through them together in a moment. Okay, so the first problem. The only thing that's being raised to that 1/3 power is the 64. So the negative remains on the outside. We have a cube root of 64. Then continue simplifying. 64 to the 1st, which is just 64. So if we break 64 down, 16 and 4, 4 and 4, you can go all the way down to the 2's, or see that it's a 4 coming out here. Bring this negative down, we get -4. The second one, y to the 2/3 times y to the 8/3. You can add those exponents together, which gives us 10/3. Again, if there's no specific instructions on which form to represent your answer in exponential or in radical form, either would be okay, but let's go to radical form. This would be a cube root of y to the 10th. If there are 10 y's, we have 1, 2, 3 groups and then 1 left over. So y to the 3rd comes out, cube root of a single y. Okay, and then the last one, we have 3x to the -4, y to the 2/3, all to the 4th power. So that 4th power will apply to each piece individually. Three to the 4th, 3, 9, 27, 81. X to the -1/4 to the 4th means multiply those together. We get x to the -4/4, which is x to the -1. And then y to the 2/3 to the 4th is y to the 8/3. Doesn't simplify. So two things to fix. That negative exponent will come to the bottom as an x to the positive 1st power. And then let's make the change on this y to the 8/3. Cube root of y to the 8th. And it'll simplify. There are 8 y's inside. We have 2 groups of 3. So y squared, cube root of, and then there are 2 left, all over x. All right. So in this video, we talked a little bit about what the exponent rules were, and then ultimately brought all of that together to be able to use those ideas on a couple new ideas where we had exponents that had fractions in them, and we saw how to simplify those in a few different ways. I will see you soon for another video.